Hi, my name is Vivek Singhal. I'm a co-founder and chief data scientist at CellStrat. Uh, we are an AI startup based out of Bengaluru, India. Uh, okay, let me just continue here. Today we'll cover types of machine learning and the various major kinds of machine learning which we see as part of artificial intelligence and machine learning area. So just a plug on our startup CellStrat. We are a small AI startup out of Bangalore, India, and we specialize in machine learning and deep learning innovation. We produce a lot of research and content in the space, and we are quite visible in AI communities on social media among deep tech researchers. Okay, so just a brief intro about myself because we have folks here from all over the world. I am the co-founder and chief data scientist at my startup CellStrat. I have worked in the US for 16 years, working for companies like IBM, AT&T, and Schlumberger, and I have also, run multiple startups, HealthyPly, Salesforce, and Rockwell. Currently, I am an AI advisor to Manipal Education Group and SimplyLearn, which are large, e-learning companies in India. And I am also, I have run AI programs at clients like HSBC, ITC, and several others. I have an engineering background along with an MBA from Atlanta, USA. Uh, I got one more message saying, so as I was saying, I have run multiple AI programs at e-learning companies. We make content for machine learning courses, and we work with several corporates for AI and machine learning programs. Okay, let me just continue here. So let's try to define machine learning. So machine learning is a field of artificial intelligence. So AI refers to the fact of training machines to think intelligently, just like humans can, right? And machine learning is you works by observing current data. So I have input data X, I have output label Y, and I have, let's say, 1,000 such data samples where I have input X and output Y. I feed into my machine learning model, and it can learn the relationship between X and Y. So this is what we are doing in machine learning. And in machine learning, we build algorithms that allow computers to learn to perform tasks as opposed to being explicitly programmed. So instead of hard coding these algorithms in the program, it is learning the algorithms. In effect, it's learning the relationship between input X and output Y. In machine learning, or ML, is what makes machines intelligent. Okay, so in that sense, ML is said to facilitate artificial intelligence, and hence it's a branch or a field of AI. So it's sometimes we use the term artificial intelligence and machine learning interchangeably, but strictly speaking, machine learning is a branch of AI overall. All right, let's continue here. So now let's look at deep learning. So what is deep learning? Deep learning is a more specialized form of machine learning, and it uses networks of interconnected computation units called neurons. So each of these circular units which you see is called what we call a neuron, and these networks are modeled on the concept of neural network of the human brain. So human brain has these kind of neural structures which we call as neural networks, and these units are called neurons, and there are billions of neurons in human brain, interestingly. And for more complex machine learning applications like image processing or speech, these deep learning neural networks are said to be more accurate, more sophisticated, and it is relatively hard to solve these kind of applications, or develop these kind of applications using classic machine learning. So the difference between machine learning and deep learning is machine learning is a general purpose algorithms for a variety of analytical applications. Deep learning is a specialized form of machine learning which is able to help us develop more complex applications like image, speech, text, etc. Okay, so just to briefly explain how this neural structure works. So this is an image which is given to us, and we are trying to detect if this image contains a car, a person, or an animal. whether it contains a car, a person, or an animal. So it's an object detection program, right? And so what we do, we take the pixels of this image. So these are, as you know from graphics word, an image is nothing but a set of pixels. We take a pixels of these image and we pass it as input neurons, right here. So this is the input layer, and then the first layer of neurons, it detects the edges. So it will detect this edge, it will detect this edge, the eye edge, the nose edge, the mouth edge, the shoulder edge, and so on. Right? These kind of edges it will detect. So the first hidden layer detects edges, right? The second hidden layer combines edges to detect corners and contours. So it will combine this edge and this edge, and it will detect a corner. It will combine this edge and this edge, it will detect this corner. It will detect this edge and this edge to detect this corner, right? And the third hidden layer combines the corners and contours to create object parts, and it will detect the full head, it will detect the eye, the nose, the mouth, right? The complete shoulder, the arm, right? So the third hidden layer will detect object parts by combining corners and contours. And the final layer, the output layer of neurons, will basically identify the complete object, okay, using the object parts. So it will be able to learn whether this image contains a car, a person, or an animal. So this is how a neural network works, and neural network is nothing but a more specialized form of machine learning. So it is still machine learning, but a more sophisticated mechanism for machine learning. Okay, I hope this is clear. Let me see any open questions coming in so far. So let me one second, just a moment, please. Okay, let's continue here. So now let's look at two major types of machine learning. Okay, so the topic for today is types of machine learning, isn't it? So there are two major kinds of machine learning. One is called the supervised machine learning. The other is called unsupervised machine learning. Okay, so we'll understand each of them in detail. So what is supervised machine learning? This happens when program learns from training data. So what do I mean by training data? I have input X and output Y, right? For example, let me discuss with the example of the most simplest of examples which I always use, which is house price prediction model. Okay, so let's say for a city like Bengaluru, India, we are trying to do house price prediction model. So what are the input factors? What would be the X, the input features, the age of the house, right? The size of the house. Let's just assume for now there are two factors which influence the price of the house, which is age and size. What is the output Y for the house price prediction model? It is the price, right? So there is two input variables, age of the house and size of the house. There is one output variable, which is the price, right? And and let's say we are given 1000 such training samples. So we are given data on 1000 houses in Bangalore, okay? And for each house, we are given, the input X, which is age and size of the house, and also the price. This is historical house information, okay? So the point here is I'm given last year's data, okay? Historical information, not latest or new. I mean, you can say recent information. So last 1 year's data is provided to me, and I can say recent historical information, and I'm given X and Y values for 1000 houses in Bangalore. So then I can train a model. I can train a model which will learn the relationship between X and Y. Okay. So a Y is some function of X, right? So I can train a machine learning model which will discover the relationship between input X and output Y. So in traditional analytics, traditional software engineering, you would have to know this relation and hard code it in your software program. In machine learning, I'm actually learning this relationship by observing current data of 1000 houses. And my model might so happen that my model discovers the relationship of this nature, right? 5x plus 3. 5x1 plus 6x2 plus 3. So let's say my model discovers this relation after model training. So x1 is what? This is x1, age of the house, right? This is x2, size of the house, right? So this is the age of the house, and this is the size of the house. So when I say I'm doing model training, I'm trying to find ideal values of weight. So this is called weight W1, which is determined to be 5. This is called weight W2, okay, which is determined to be 6. And this is called weight 0, or also we use the term bias B, okay. So all what I am trying to do in model training is try to find ideal values of W1, W2, and B, right? So this is what my machine learning model trainer achieves. So given training data samples x1, y1, x2, y2, x3, y3, right, shown in blue here, I'm able to infer a function, a relationship between x and y, okay, and using this function which has been learned. So this is a trained model, right? So this is a, now I call it a trained model. I have discovered the relationship between x and y, right? So y is some function of x, and it could be that equation which I have shown at the top. And then I can use this equation to predict future values of y. For let's say a new house gets built in Bangalore, later this year. So using this trained model and using the age and size of the house, I can predict the price of the house, right? So once I learn the model based on historical house price data, I can then use that trained model to predict the future, the price of future houses which come in my system. All right. So what is happening here? Training data contains input and desired output data. So this contains X. It also contains the corresponding Y for historical data, right? And so we have to have clean data. We have to clean the data, and we have to do data pre-processing. And this is indeed an intricate task. We have to make sure we have clean data. So there's a data pre-processing step involved. And let's say new data is being created every day. As new houses get built, so we are getting newer data observations, right, from the market. So we can create a more and more LearnNet or intelligent program. So we can retrain the model again and again and again so that it can become more and more intelligent. It is also accounting for the more recent houses or current houses being built. All right. So my model will always become more and more accurate because I continue to feed it more data. Okay. Any questions on this? What is supervised learning? Okay. By the way, why is it called supervised learning? Because I have input X, I have the corresponding output Y provided to me. Okay. So input X, output Y. So it's just like teacher teaching a class, right? So teacher says this is a problem statement, this is the solution, right? When a teacher is teaching a class, teacher provides a problem statement to the students, and teacher also provides a solution, right? So X is the input factors, Y is the output for that X. So that's why this is called supervised learning, because for every X as input, I have the corresponding Y output level provided to me from historical data. All right. That's why this is called supervised learning, because output is also being provided. So it's supervised in that sense. Somebody is helping us by providing us the output level Y. Okay. So I don't see any questions. So in that case, I'll continue. So so this is describing what I just did, right? So there are 10 training samples provided to us, and for each training sample, we have X1, we have Y1, right? For X2, historical training sample, we have the corresponding output level Y. So X represents the input features and Y represents the output level. For example, the features which influence the house price go under X, the price of the house goes under Y, right? And I then, using this historical data, which is a price of 10 houses or 10 data samples, I reverse engineer the relationship between X and Y. In other words, I train the model or I learn the algorithm, okay? And my learned algorithm may look like any of these kind of equations, right? So there could be more complex equations also. Like you can see here, if there are two features x1 and x2, x1 is simply to the power of 1, but x2 is to the power of 2, so it's x2 squared. Okay, so relationship between x and y, if this is y and this is x1, so compared to y and x1, it is a linear relationship, right? x1 to the power of 1, right? This is what this means. So x1 to the power of 1. However, x2 is different. x2 as a square, so it's a polynomial relationship. Okay, polynomial means this kind of curve. So compared to x1, y is simply 5x1, but compared to x2, y is 3x2 squared. So relationship between y and x2 is a polynomial relationship, a curvilinear relationship. It's a curvilinear curve. It's curved. It's a square 2-degree polynomial because there is square. And y and x1 is linear relationship, hence it's a straight line. All right. So obviously there are two dimensions on the input. So I have a basically a three-dimensional problem. This is x1, this is x2. For this equation, I'm referring to that equation which is shown there. So relationship within y and x2 is something of this kind, but the same curve against y and x is a straight line. All right. So I can't show it here in a 3D format because there are two input dimensions and one output dimension. Okay. So it could be any equation. It could be simply y is equal to 25x1. It could be anything. So equation is learned on the fly. And what we are learning is we are learning the weights. This is called W1 weight, like this. Y is equal to W1 x1 plus W2 x2. Let's say assuming there are two input features plus bias B. So this is how we write this equation. What model is trying to learn is the value of weight. Okay, and bias is also actually a weight. So this comes from a linear algebra days. If you remember, and you remember that we used to have an equation of this kind: y is equal to mx plus b, right? So m was what? M was the slope. So m was the slope of this curve. So in machine learning, instead of using the letter m, we choose to use the letter w, which is weight. Weight just means how much weight of x influences y, right? What is the weightage of x when determining y? And b simply means the bias. So b is the value of y when x is 0. So when x is 0, this length is called b. So it is the offset from origin, because I simply have to substitute x is equal to 0, and then in that case y becomes equal to b, right? So y is the value, b is the value of y when x is set as 0. So this is the line where it doesn't start from origin, it starts from here. This term is called b, bias, the offset from origin. Okay, because this is a point where x is 0 but y is not 0, it still has a value of equal to b. Okay, so once I have learned this model, then I can deploy this in production, this trained model, this equation, this algorithm, and then for any x new input, we can predict the y using this trained model or trained equation or trained algorithm. Okay, I hope this is very clear to you all. Let me see if there are any questions here. So there is a question, how are we getting the weights? We get the x1 and x2, and we are trying to find y and w1, w2, w3. Okay. See, the model learns w1, w2, w3. We are given x values and y values from historical data. The model learns the values of weights. This is what we mean by machine learning. This is what we mean by model training. We need to learn the values of weight w. W1, W2, W3, however many weights are there, right? If there are three features, there will be three weights plus a bias weight also, right? So this is the output of the model. In traditional programming, you would have to hard code this equation in your software program. In machine learning, it is learning the equation. When I say it is learning the equation, it is learning the weights by reverse engineering the relation between x and y by observing the current data, of x and y combination. Okay, so we are learning the weights. So there are two equations and many unknowns. Who generates the equation? The model learns the equation. Okay, how to deploy the model in production? Could you please give the high level overview? Well, so it will be a usual program in a programming language like Python, and I can deploy it in. I'll actually demonstrate a Python program of machine learning at the end of this. I'll demonstrate a Python program at the end of this session, so you get an idea of it. Okay, let me, in interest of time, let me continue. I do see quite a few questions coming in, but let me just continue here for now. I'll address a lot of these questions as the class goes by. Okay. So there are two kinds of machine learning algorithms. In one, the first type is classification, the second type is regression. In classification set of machine learning algorithms, I'm trying to train a model to answer the question, what class a data sample belongs to. In the second type of, in regression type of machine learning algorithms, I'm trying to answer the question, how much of something. An example, social media sentiment analysis has three positive potential outcomes: positive, negative, or neutral. Is the rating of Mr. Donald Trump, the US president, is it positive in Twitter? Is it negative in Twitter? Or is it neutral? So how many people have positive view of Donald Trump? How many people have negative view? How many are neutral about it? So the question I'm trying to answer is what class? There are three classes here, right? Class number one, class number two, class number three. So there are three classes, and I'm trying to train a model which can learn from historical tweets, and then for any new tweet, it will be able to identify whether the sentiment in that tweet about Donald Trump is positive, negative, or neutral, right? And this works when the output is finite and discrete values. So you can say there are only three possible outcomes here, right? So we are trying to train a model which will detect the class of a data sample. Okay, and you can see the diagram here. So there are two classes of data sample, black dot and white dot. We are trying to find the equation of a line which cleanly delineates or segregates the black dots from white dots. So here I have given three lines to you. Okay, I'll remove the color, otherwise it hides the color of the line. So you can see there's a blue line, there's a red line, and there's a green line, right? Now notice something. So green line is not able to classify the data. So it is a bad classifier. It's wrong, right? Because when I say classifier, I need all samples of type A on this side, all samples of type B on this side. I cannot afford or allow mixture to happen. If there's a mixture, it's not a good classifier. So green line is ruled out. It's not a good classifier. It did not segregate white dots from black dots. The blue line segregates correctly, right? The blue line segregates black and white dots correctly. However, the problem is too close to them, right? So there is a potential for error. A black dot might come in the wrong zone. A white dot might come in the wrong zone. There is a potential for error. So I don't like the blue line either. I'll reject this also as a classifier. Okay. Now there is a third line I discovered, the red line. This is best, isn't it? Because this is maximum distance from the nearest black and white dot, right? So this is my best classifier. So equation of the red line is the best classifier line. And once I discover the equation of this line, it will still look like some function of there are two input variables, x1 and x2, right? So this equation will have the form x, some function of x1 and x2, right? So this will be the nature of this equation of this line. And then once I found this equation, I've discovered this equation, then I can use it to predict any new dot. So a new dot which comes into the system, I merely have to apply this equation. This is a new dot which comes into the system. I merely have to apply this equation and predict the class of the new dot. All right. So this is how classification works. First you train it on historical data, then you use the trained model to predict the class of the new dot which comes into the system. In regression, what is happening? I'm given these blue dots, right? I'm given these blue dots. Okay, so blue dots are the input. Okay, blue dots are the input. The red line is the output of the model training. See, in traditional programming, the equation of the red line would be the input, or it would be hard coded. But in machine learning, I am learning the equation of the red line. So the equation of the red line is actually the output of the model. So by giving historical data samples, the blue dots, which are input data samples, I am able to learn the equation of the red line, and that equation is the line fit. So you can see that this line fits most of the blue dots quite sufficiently. Well, ideally I would like all the blue dots to be on the line for a perfect accurate model. But guess what? If I try to connect all the blue dots, what will happen? It will be like a child trying to connect the dots, right? So I'm trying to connect all the blue dots exactly, precisely, to 100% degree. I won't get a workable line in this case, right? I'm trying to connect all the blue dots. This is not a good model. Okay, so I would rather accept a compromise. I'll try to draw a linear line which satisfies the blue dots to the greatest extent. Okay, so this is also called a line fit process. This is called regression or line fit. So in regression, I am trying to fit a line to available data samples. This is also called a line fit method or regression. Okay, and sometimes it can be curvilinear. So let's say my samples are of this nature, right? A straight line won't fit it, right? A line which will fit is more like a curvy line, right? So this is a polynomial regression. Okay, so the straight line means linear regression. Linear means straight. If the dots are on a curvilinear structure, it would be polynomial regression. Clear? So here the question. So once I have the equation of the red line, then I can predict. Let's say a new dot comes here. I know the equation of my red line. Let's say it is simply equal to y is equal to 5 of x. A new dot comes here. X is equal to 20, right? Let's say a new data samples come in my system. I just have to substitute the value of x. 5 into 20 is 100, right? So this was my trained model, which I found after model training. A new data sample came into the system, something of the kind x equal to 20. I just substituted x value in this equation, and the predicted y, we call it predicted y predict, is 5 into 20, which is 100, isn't it? So using the trained model, I am able to predict the output y for any new sample x. All right. So this is I am doing how much or how many prediction. When I do how much or how many, it is called regression. When I do what class, it's called classification. And here output is a continuous number. You can see the output is on a continuous line curve. It's not discrete. Here we had finite and discrete output classes, only three classes in this example, right? But here it's a continuous number. For example, house price regression. So house price is not a classification problem. House price prediction model is a regression problem because house price can be any number, isn't it? It will be a continuous line. Whereas sentiment analysis about Trump's performance on Twitter is only having three classes, right? Also, for example, news article is news article of type sports, politics, or entertainment. Three discrete classes. That would be a classification problem to classify the news article. Okay. And another example is when I given humidity levels in my area, what is the environmental temperature? So the equation could be of something of this kind. Given the humidity level, which is represented by x, what is the temperature? So I can train a model which can predict temperature for humidity levels. And when I say I'm training the model, I'm trying to learn the ideal values of weight W and bias B. And since this is a linear relationship, it's called linear regression. If it is a polynomial relationship of this kind, it is called polynomial regression. Okay, I hope this is clear. Let me continue here. So next we come to unsupervised learning. Okay, unsupervised learning, what is happening? Here I am given x, y is simply missing. Y is missing. I am only given x. So you might ask me, well, what can I do with x? There is no y. So how do I do model training? So there is no concept of relationship between x and y. There is no such concept. Okay. Why? Because there is no y available to begin with. So this process doesn't work. That was supervised learning. So, but I can still do something called unsupervised learning. I can do something with x. So let's say I'm given some data samples, x only, no y. Okay. I can do unsupervised learning. In one of the unsupervised learning things I can do is clustering. So I can say these samples belong to one kind of cluster. These samples belong to another kind of cluster. All right. So this is cluster 1. This is cluster 2. I can group the points. I can group the x points. Okay, there is no output y, so I can't do the things I did with supervised learning like regression or classification. But I can still cluster them based on similarity match. So this technique is called clustering. And clustering is an example of unsupervised learning. Okay, and one of the popular algorithms we use for clustering is k-means clustering. And here what is happening is, based on similarity, these dots appeared in cluster number 1 and these dots appeared in cluster number 2. So we are saying these dots are of very similar nature. These dots are of very similar nature. For example, grouping newspaper articles. So let's say Google News Feed is collecting articles from all news portals, is syndicating news articles from different news portals. It might say, I want to classify news articles into 3 sections of the Google News portal. So this cluster will have political news, this cluster will have entertainment news, this cluster will have sports news. I mean, clearly, you don't want to see a sports news article in political news section, right? You don't want to see a political news article in entertainment news section, isn't it? So Google a newsfeed engine will try to classify the incoming news articles into different categories and place them in the right sections of the Google News portal so that people have a very clear understanding of the section of the portal they are reading. If I'm trying to read political news, don't show me entertainment or sports news, and vice versa, right? So I can cluster news articles into these 3 clusters using k-means cluster or other kinds of unsupervised learning techniques. Okay, so this is what we talk about here. 3 different news articles. So this sounds like classification, but is different from classification which we saw in the previous slide, because there X and Y data was given to us. So you could classify things into different classes. Here also I'm classifying stuff into different categories. However, I'm doing it without the Y being present. I'm using similarity match between similar looking data samples. Okay, this is called unsupervised learning. It is used to discover relations or hidden structures within the input data, which only comprises of X data samples, but no corresponding output level Y. Let me continue here. I think we just saw clustering just now. So I'm given a set of data samples and I'm trying to classify black dots from blue dots, right? So this is the boundary line which is able to distinguish from blue dots to black dots. Okay. So this was clustering which we already discussed. So I'll keep moving here. So these are some supervised learning algorithms which we teach in our machine learning programs: k-nearest neighbors, or KNN for short, linear regression, logistic regression, yes, support vector machine, decision trees, random forest, and of course artificial neural networks, which fall under the branch of deep learning. Okay, and these are some unsupervised learning algorithms, for example, autoencoders, dimensionality reduction, k-means clustering, which we just studied in the previous slides, and also association rules. Okay, so I'm not going to review details of these algorithms. These are, each of them is a big subject. Okay, and our different webinars try to cover some of them on a high level. Now let's understand a basic ML process. Okay, let me just see here how I am doing on time. I will make sure I don't overshoot the time because yeah, okay. Once let me explain this, then I'll address some of your questions. I see quite a few questions are coming in, but let me just first explain this. So there are 4 major steps in machine learning, okay, and we are primarily talking about supervised learning, not unsupervised learning. So we have to do data preparation, step for number 1. In data preparation, we are given input X, output Y. we may have to do something called feature engineering. So we may have to decide which features matter. For example, in house price prediction model, age of the house matters, the size of the house matters, but does rainfall matter? Rainfall in Bangalore, does it influence the price of the house? Yes or no? So so some amount of feature engineering is needed where I select and find the right features, right? And then what we typically do, if we are given 1000 data samples, we try to preserve 80% for training. So I'll say out of these 800 will use for model training. Okay. 200 will be used for the test step. Okay. So I preserve 80% for training and 200 for testing. So next comes training step. And here I'll be using the 80% of the original data which was reserved as training. Let's call it train underscore x. Using this, I reverse engineer or discover the relationship between x and y. Once I found this model, the model has been learned. I pass this model to the testing or evaluation step, and here we use the trainee. So trainee is nothing but the 20% of the data set which I had preserved before, right? So 80% I used in training step, 20% I use for testing step or validation or evaluation step. And using this training data, I would like to validate the accuracy of my learned algorithm. So this learned algorithm is based on training data, but I still need to check its accuracy by testing its accuracy using the testing data. So this is just like a teacher teaching a class, let's say a high school class, a maths teacher, right? So maths teacher has 10 problems in the book. So the teacher will teach only 8 of the 10 problems. So let's say in a maths book there are 10 problems for a high school maths class. So the teacher will teach only 8 problems through the year. The teacher is going to reserve the remaining 2 problems for the final exam, isn't it? The teacher doesn't want all the kids to cram all the 10 answers, right? So teacher will teach 8 problems in the class, but reserve 2 problems from the maths book for the final exam, so that she or he can test the understanding of the students when they undergo the final exam, right? So you don't want to train the students on all the problems, otherwise all of them will cram it and all of them will score 100% in the final. To really test the understanding of students, you want to keep some problems for the final exam and not teach them in the class. Same exact process happens here. We keep 80% of the data for training and 20% for testing the accuracy of my trained model. Okay, I hope that analogy makes it clear. And if I find that during testing the accuracy of my model is low, then I'll send it back for retraining. So during testing, during the final exam, if a student fails the final exam, the student has to repeat the class, isn't it? The student will continue to repeat the class and not be promoted to next class unless and until they are able to pass the final exam, right? So, same way, we'll keep retraining the model till it passes a test or evaluation step. So, the test or evaluation step is critical for the model to be promoted to production deployment. If it passes my evaluation or test step, the model is then sent for production deployment, and using this algorithm, this trained model, and now fully tested as well, I can predict output Y for any new input X. And the model trained could be any equation form as we have seen, right? There is no limit to the complexity of these equations which the model might be able to learn. All right. And if there is one feature, it's just X and Y. If there are two features, two input features, X1 and X2, then output Y. I could have hundreds of features. Okay. So for example, trying to predict stock prices in a Bombay Stock Exchange or New York Stock Exchange or London Stock Exchange, there are thousands of features. So X can range X1, X2, X3 up to X thousand features could influence stock price. What is Y? The price of the stock. But there could be thousand input features, so the equation will be humongously complex, isn't it? Now when I'm sending the model for retraining, I might want to change something so that my model training is more accurate. So I may try with more training data, I may increase the complexity or capacity of my model, or I might change the algorithm. Let's say I was using linear regression. I might try polynomial regression. The polynomial regression also does not test well then I might try decision trees. If that doesn't do the trick either, I might try artificial neural networks, right? So I could change the algorithm, I could change the complexity or capacity of the model, or I could increase the amount of training data available to try to have more accurate model training. Okay. So when I'm retraining, I generally try to change something, right? So now let me address some questions before I proceed further. Okay, I'm just reading your questions here. How to deploy the model in production? Could you please give the high-level overview? Well, I'll be demonstrating one program. So once you have a program, you can then run it in batch mode and get data feeds through Excel file or RDBMS and continue to do model training and predict the outcomes, right? You can also integrate Python machine learning programs with web applications using a certain API called Flask. So Flask is a flask like a jug. So Flask is a Python API which can be used to output or render Python output to a web page. It generates HTML code. Okay. So is the number of weights is equal to number of features? Precisely correct. So normally number of weights is equal to number of features. So if there are 1000 features, I will have to learn 1000 weights, typically speaking. I will have one more, by the way, which is the bias B, right? So it will be number of weights is equal to number of features plus one, right? For the bias, the B offset value. Can we use same linear regression method for multiple features? Absolutely. I could have 1000 features. If the relationship between y and all the 1000 x values is linear, I can use linear regression. What if we have multiple features? So you can have linear. If the relationship is linear, you can use linear regression. If the relationship, let's say one feature is linear, is just x1 to the power of 1 plus x2 square plus x3 cube. So you can have a polynomial relationship between y and x different x's. Okay. Can we do classification first and feed the result to regression? It depends on the solution, the problem. So in some cases, maybe you want to classify stuff first and then do regression. That really depends on the problem statement. Can we get these slides? Well, this video is being recorded. It will be available on our YouTube channel. So for intellectual property reasons, we don't give slides, but our video is available to you all the time on our YouTube channel. Okay. The link to our YouTube channel is on our meetup page where you found this webinar. Okay. So we don't send slides. Model gets trained based on reading the data once. So yes, so model reads the data. So it may just continue to iterate the training step till the accuracy on the test step is very good, right? If I achieve 90% accuracy, I may say, okay, I'm satisfied. Let me put it in production, even though it's 90% accurate. What if we get egg crew shaped like graph? I mean, I don't know what is meant by egg crew. I showed you a polynomial graph, so I don't understand what is meant by egg crew. Kindly clarify. When you send the model back to data to learn again, how does it know it should not generate the same model as last time? So that's a technique. So when I take you through the regression, webinar, there we'll explain how the model doesn't generate the same, the model training does not generate the same exact model every single time. Basically, it's changing the weights. In each iteration of model training, it changes the weight slightly. So the equation keeps changing between every training iteration. Okay, so that I'll explain in our regression chapter when we get to it in one of our upcoming webinars. In case of retraining, assuming if we do not have more data to include, is it recommended to duplicate the 80% of data, say 4x times, and then train on this? If you have less data, you cannot just copy the data 4 times and assume it's increased data. That's not correct. Okay. So let's say I have 1000 data samples and you are saying this data is not sufficient. So what you are trying to do is just copy the 1000 data samples another 3000 times to make 4000 data samples. No, that is not correct. You need real data. So you need real unique data. You cannot have same data replicated 4000 times, right? Or 4 times. That is not correct at all. So multiple hills shape. So instead of saying multiple hills, let me show you what you mean by multiple hills. Let me see if this is what you mean. So when we say, well, yes, you can have all kinds of relationship between X and Y. Okay, you can have all kinds. So there is no specific limitation. The relationship between X and Y can be quite complicated. Right? It can be extremely complicated. So that's just the reality of the word. So I'll tell you something. Let's say this the relationship between X and Y is is not linear, is not polynomial. Instead, it looks like this. Okay. So relationship between X and Y is extremely complicated, which happens in real life, right? It is haywire. What do? You cannot use classic machine learning. This is where deep learning is used. So we bring the horsepower, the firepower of neural networks. Okay. So neural networks can discover any arbitrarily complex relationship. All right. So where classic machine learning fails, deep learning neural networks take over. Okay. So deep learning neural networks can discover any arbitrary relationship between X and Y. All right. This is the power of deep learning. Okay, this is why artificial intelligence is becoming so hot, because we can do very complex processing where the relationship between input and output is extremely difficult to model. Okay, but neural networks provide me that capability, that horsepower to do that. How neural networks function, I explained you briefly in the beginning. It's a massive subject. Couple of webinars address the deep learning aspects. But if you want in-depth training, I suggest you go through our training cycle. So we have courses in machine learning, deep learning, and advanced neural networks. All right. I'll just come to that briefly in the end. For now, let me just continue. So, so I already explained the concept of reserving, some amount of data for training step, some for testing step. Sometimes we may also reserve some data for a super final exam. So this is my class throughout the year. This is my final exam. This is my super final exam. So I am saying I am not satisfied with testing the understanding of the child in the high school one time. I'd like to test him one more time. Okay. So there is a super final exam. So this is a final exam. This is a super final exam. Or you can call it, this is semi-final exam, this is final exam. Either way you want to put it. So we might reserve 70% for training step, 20% for test step or semi-final exam, and 10% for the final exam. Okay. The last step is in this course called validation. Okay. So we may split the data in this set also. So let's add 1000 training samples initially. I may say 700 are used in training step, right? 200 are using in the test step to test the accuracy of my model train, and 100 are used for yet another final validation testing step. Okay, so I may split the data that way also. Let me just continue here. One of the problems which happens with models is they can overfit. Okay, so you can see this is a badly fitted model. It is quite inaccurate, right? It's only maybe 60 to 65% accurate. It doesn't pass the dots. It's not close to them, right? Maybe I could have, but when I try to do, I can do a polynomial fit, right? So that a line passes through all of them. So I did a polynomial fit here. So this is better, isn't it? So this is a polynomial fit. This one is a better model because it fits the lines, the dots nicely, right? This is overfitted, by the way. So overfitting means that it is trained too tightly, right? I'll give you an example of overfitting. Let's say my daughter goes to a school in Bangalore, India, and the teacher is teaching my daughter Indian history, right? So my daughter is learning Indian history. Now, if an American comes along and asks my daughter something about American history, right? My daughter cannot answer questions on American history. She is only trained on Indian history, isn't it? So this is called overfitting. If I am trying to develop a diabetes prediction model for a population in India, so because Indians have certain body characteristics why they get diabetes, right, in older ages. So if I use my diabetes prediction model trained on Indian data set and try to test the accuracy of my model, let's say with European data set, it won't be well fitted, right? Because the propensity or the tendency to develop diabetes in Europe is significantly different than the tendency to develop diabetes in India, right? Lifestyle habits, diet habits, and lots of other changes happen, right? So this is called overfitting. So my diabetes prediction model is overfitted to Indian body type, it will not work for European or American body types, right? So you understand the meaning of overfitting. Right now they are training driverless cars in United States and some other countries, right? Companies like Tesla, companies like Uber, even General Motors and Ford. Well, they are training those driverless cars on American roads, let's say. So you cannot possibly expect that those trained cars can operate in India. The driving conditions in India are vastly different. That means those driverless cars are overfitted to US driving conditions. They won't work in India. So this is the meaning of overfitting and underfitting. All right. So we have to always take care of this in machine learning. We have to find the right fit, just the appropriate fit. We don't like underfitting, right? Underfitting is bad, so is overfitting. We want just the right fit. All right. So this is very important concept, and when we do machine learning model training, there are a lot of tuning parameters to achieve, appropriate fitting. So this is just some examples of supervised learning, right? Where input X and output Y is given. So input X for a speech chatbot, I'm given voice recording, right? And then I am given the corresponding digital transcript, okay? And I can train a speech recognition chatbot, just like the Amazon Alexa chatbot or Google Assistant or Apple Siri, which you might have tried, right? So I need input X voice recording, which is np.mp4 file. I need the output Y, which is the digital transcript. Basically, it describes what the voice or speech says. I can train a speech recognition chatbot, okay, using historical stock market data and the corresponding future stock market data. I can trade I can train a trading bot which can automatically predict future market prices for shares and stocks. Using historical photographs and corresponding caption, I can automatically I can train a image tagging application just like Facebook does. When you tag, when you caption photographs on Facebook, you are basically giving training data to Facebook AI engine, which is learning how to automatically tag images based on historical photographs and their respective captions. So there are countless such, interesting supervised learning applications. I'm not going to go through all of them, but this is just showing you a couple of applications for supervised learning. So this table is, by the way, taken from Harvard Business Review. There was a very nice article which you can Google and find on supervised machine learning systems. Let me just continue here for interest of time. So our final type is reinforcement learning. Okay. So this is the third type of machine learning algorithm. It's not supervised. It's not unsupervised. Here what happens, I train a system by giving it rewards. So let's say there is an agent in state S1. It is observing the environment. The agent takes action A. In response to action A, the system grants it reward R. Okay. So then the state of the agent changes from S1 to S2. Okay. State of the agent changes from S1 to S2. And so by giving this reward, I'm telling the agent, the system is telling the agent that this action was a desirable action. If the agent does not get a reward, the agent will not repeat that action. So action A is only repeated if the agent is granted a reward. This is just like training my pet dog to fetch the ball. So when I got a new pet dog and I'm saying shoo, fetch the ball, but the dog doesn't move, then I show a cookie to the dog. I indicate to the dog, if you fetch the ball, I'll give you the cookie. So dog is looking at the cookie, but dog is looking at my face expression that I am asking the dog to go and fetch the ball. If the dog fetches the ball, I give the cookie to the dog. So dog starts learning to get the cookie, it has to fetch the ball. Same way I train a reinforcement learning system where the system learns desirable behavior by by virtue of rewards and penalties. Okay, so if it gets a reward, it knows this is a desirable behavior. If it gets a penalty or does not get a reward, it understands it's not a desirable behavior. It won't repeat it again, right? So this is the technique which is often used in video game systems, in driverless cars or self-driving cars, and also we teach robots how to walk. We also teach robotic arms, which are used in industrial segments. Okay, so this is a new area relatively in deep learning. and it has revolutionized some of these industries, and there's a lot of research happening in this. The algorithms are not very accurate as of yet, but there's a lot of research happening from different universities around the world around reinforcement learning, also called rewards based learning. Okay, so reinforcement learning or rewards based learning, this is the third major type of machine learning, if you will. Let me just continue here. So let me just take some questions, then I'll address some of the career inquiries which we get. I'm totally out of time. Okay, so I ran out of time, but let me address the questions. What is the use of splitting into test and validation? If the test result is low and validation result is high, how good we consider the model to be? See, we will not send the model for validation step if the test did not pass. Before the model is sent to validation, it needs to pass the test. I'll keep retraining the model, keep rerunning the training iteration till the test passes. Only when the test passes will I send the model for validation testing. Okay. What is the difference between data science, data analytics, and machine learning? Well, data science refers to the overall area of data. So it could be data engineering, it could be big data in Hadoop, even machine learning can be considered a branch of data science in that sense because it deals with data, right? So data science is the overall area. Data analytics refers to the concept of doing analytical insight on this data using different tools like SAS, SAS, or IBM SPSS or IBM Cognos, SAP Analytics, and so on. Uh, right? So that's what is the difference between data analysis, data science. Machine learning is a newer area, the most glamorous area, incidentally. Machine learning is the process of learning the relationship between different kinds of data, right? Input X and output Y. So machine learning is also interrelated to data science. It can be considered a branch of data science in that sense. And it is achieving analytics for us, but instead of doing hard-coded analytics algorithm, it's learning the algorithm. So that's the difference from traditional data analytics and machine learning. Once, can you say about usage of validation data? Okay. So as I said, I first do the training step, then I do the testing step, then I do the validation step because I'm not satisfied just with one final exam for the kids. I want to test their knowledge a second time. Okay. So the validation step is one more exam after the testing step. Okay. And the data, 10% of data is reserved for validation, 20% for testing, and 70% is used for training step. Okay. Do you undertake reinforcement learning in your course? So one of our future, right now we have three courses. Let me just see, let me answer some of your career questions with these slides before I take your career related. There are some career related questions. So the demand for data scientists is huge. So not going to spend time on this. This is a well-known secret, right? There's not enough data scientists in the world. Okay, what are the skills needed for machine learning and data science? So typically, if it is a technical data scientist, we like them to know programming. In any programming language, we usually teach Python, and they should have learned mathematics till high school at least. Of course, we'll be teaching machine learning. They need to learn data engineering and visualization skills because it's all about data and how you plot it in different intuitive plots. And of course, they have to have good communication skills to because it's an interdisciplinary science. You have to deal with management, you have to deal with the data sources, to deal with the programming teams. So a data scientist is an interdisciplinary area, hence excellent communication skills are required. What does a data scientist do? Given a question and bunch of data, they know how to leverage computational tools to slice and dice the data to answer or raise certain questions. Basically, a data scientist is able to derive useful insights or useful inference from data. Okay, so deriving useful insight or useful inference from the data. That's what a data scientist is able to do using some of these computational tools. Okay, so I'm going relatively fast because I am much over time. So you can see here I'm showing career tracks for various kinds of data science professionals. So I'm lumping AI, ML, and data science in one box here. So you can generally consider them one. So below that, I have one technical track shown and a non-technical track which can be adopted by managers. So a managers, even though they are not developers, they can still train themselves to be AI consultant, AI solution specialist. Even sales and marketing can undergo this training. So you can continue your main career path, that of solution consultant, program manager, quality assurance, tech marketing, sales, HR, anything. But you could still train yourself to be an AI specialist, being in a different area also. For technical data scientists who know some programming at least, there are various areas. So you can specialize in big data, which includes Hadoop, Spark, Apache, Kafka, Hive, and so on, right? Some of you might be in that area. But the most latest, the most glamorous area of technical data science is artificial intelligence, which basically means machine learning and deep learning. So if I were you, I would leapfrog to the latest and greatest area directly. There is no prerequisite of having big data expertise before you can learn machine learning and deep learning. And below machine learning, deep learning, there are specialized areas like predictive analytics, computer vision, text and natural language processing, robotics, driverless cars, and so on, right? So this, it takes almost 1 to 2 years to train a good intermediate level machine learning data scientist. 1 to 2 years. You have to do a series of courses, lots of projects and practice to become an intermediate level data scientist. For a world-class data scientist, you have to spend many years in this area before somebody can call you a world-class data scientist. The salaries are through the roof. Salaries are not a problem in this area. The world does not have enough data scientists, as we know. Salaries are very high. Let me continue. So this is an introduction to our three-course program. We have three courses which I teach online. I personally teach these courses. We have just started a batch for core machine learning, which is like a 30-hour touch program with me instructor. Then 1 month of self-practice. Then course number 2, which will launch in November in deep learning, right? It will launch on November 13, interestingly. And and then again 1.5 month break in the Christmas vacation period. Then we come back and take the advanced neural network course. So it's a 3 course program, and this lasts almost 6 to 8 months to complete. And if you do all 3 courses with us, we issue a PG certificate in artificial intelligence from my startup CellStrat. And each course is independent. You can do them and get individual certificates. By the way, there is a prerequisite. You cannot jump to deep learning without doing machine learning. You cannot jump to advanced neural network without doing deep learning. All right. So I hope this is clear. You can find these programs on our meetup page and sign up for upcoming deep learning course. You can also start my machine learning course, which is started just yesterday. But yes, if you have to enroll by tomorrow if you want to join my current September batch of machine learning. If you don't enroll by tomorrow, then you can pretty much go to the next course, deep learning in November. But the problem is you would have to have machine learning expertise before you can understand deep learning. All right. So there is a prerequisite. If you want to join my machine learning course by tomorrow, contact me immediately. By tomorrow, I need to sign you up because otherwise you would have missed a lot of content because I already took one class yesterday. All right. Let me continue here. So this just shows the curriculum for our upcoming deep learning course, which will start on November 13. We start with intro to deep learning. And we use Google TensorFlow as the chosen tool. Python TensorFlow is the tool we'll use for deep learning and for neural network development. And this is a curriculum for a deep learning course, okay, it's a 5-week course starting November. It's an online course every Tuesday and Thursday in the evening, India hours, 7:30 to 10:30 p.m. India time, 9 a.m. to 12 p.m. US Eastern Time. Okay, it's an online course which I'll be teaching personally, and it has a lot of resources. For example, there are tons of programming demos, hands-on coding exercises, quiz and assessment. There are a couple of capstone projects, and me and my senior data science faculty are teaching this course. You can chat with our industry expert network. And the sign up link is given here. You'll also find it on our meetup page for Disrupt 4.0. Okay, so you can register. There are early offers going on signing up for this November course. If you register towards the end, you'll end up paying slightly higher. So that was the session. Now let me answer some of your questions. Unfortunately, I'm out of time, so I can't show you the program I wanted to show. We have a webinar coming this Wednesday again, where I'll be explaining basic regression, and I'll try to keep some time for the programming demo. Okay, so you can come back and attend my regression webinar this Wednesday. How to shift, a question which has come now, how to shift to new career in this path when I have 10 years in other. See, if you have been doing web development, and so you have to plan for a 1 year learning journey. If you're trying to penetrate the area of machine learning and deep learning, you have to plan to train yourself over a 1 year period. And you definitely have to do the 3 courses I have mentioned to you, starting with machine learning, deep learning, and advanced neural network. I mean, there are other learning institutes as well. We are not the only ones in town, but that you will have to evaluate. I have no comments there. Okay, you can check our YouTube webinars on our YouTube channel, see some of our samples, just like today's webinar. We have lots of free YouTube webinars on our YouTube channel. Uh, are you going to conduct more webinars? Yes. So we conduct webinars every week. If you follow our meetup.com page, you'll find our webinars there. So our next webinar is this Wednesday, where I'll be taking a webinar on basic regression techniques like linear regression, polynomial regression, and how weight training is done. Okay. So you can join our Wednesday webinar as well. Okay, so I am way over time. So any final questions before we call it a day? So this is the time you can ask me any final questions for today. Okay, so the last 10 seconds. All right. So thanks for your time. Oh, there is a question here. Sir, I am an engineering student. I am interested in AI. So what are your suggestions? Well, my suggestion is do these courses, because these courses will give you intensive machine learning project practice and coding practice, and prepare for a 1 year learning journey. It takes about 1 year of continuous courses and, and 1 year of continuous practice with projects and coding before you can call yourself an intermediate data scientist. So it's not magic. You can't do a 1 month course and become an expert in machine learning. Okay, it's like a more like a 1 year journey of continuous learning through multiple courses. What is advanced neural network course? So in the deep learning neural network course, the course starting in November, I'll cover introduction to neural networks, how neural networks are trained, what is meant by deep neural networks, things like overfitting, regularization, gradient descent, etc. Okay, it's a 5 week course, 30-hour touch program. In advanced neural network, I will cover convolutional neural network, recurrent neural network, and something called autoencoders. Okay, so that's what advanced neural network is. It will cover more advanced variations of the neural network. The deep learning course will cover the core neural networks. Okay, what is the rate for these courses? Each of our courses is priced very economically. It's about 10,000 rupees, all inclusive Indian price. Okay, each of our courses is very economically priced compared to some of the other learning companies. So across 3 courses, you will pay, about 24,000 plus taxes. Okay, so it's about total will be around 30,000. So it's very economically priced compared to other, because we are trying to keep it economical for most of our audience. Okay, so rest of the information you can find on our meetup page. Just kindly go there and you'll find all the information about these courses. Okay, so I thank you for your time and patience, and I went over time, but you all have been listening attentively. I really appreciate that. I look forward to seeing you in our future webinars. Okay, good night and good day.